So, friends, on behalf of Bharati Vidya Bhavan, IKSL, we extend a very hearty welcome to all of you for the second talk under the IKS series. As you know that the Bhavans, we set up the IKSL very recently in order to bring back the legacies of the ancient India in terms of the not only the guidelines but inspiration from the government of India. So we started at the initial stage through some talks, and then possibly we'll take out some research projects also, some exhibitions, some other performances out of the on the table. So today on the second talk we have a very interesting topic, and that's the talk on the great Indian mathematician and astronomer Aryabhatta and the Aryabhatian mathematics. As you know, that Aryabhatta has been the legendary figure as far the India goes, Indian literature goes, Indian what do you call treasure house goes. And I mean to say, many of us have got some knowledge of the contribution of the Aryabhatta in the Indian mathematics, and some of them may not have that much of an exposure to the contribution by Aryabhatta. So we thought let's have a discussion on this particular topic. It's a very interesting subject, and we request, I'm sure that it's going to be very interesting and informative session. To talk on this particular topic, we with a very eminent person, a very scientist with us, and Dr. S S Prabhu. Dr. Prabhu is a physicist, a scientist on the Tata Institute of Fundamental Research in Bombay, and he has been what we call a hardcore trainer, teacher, and a researcher. Now he has specialized in the area of the femtosecond pulsed laser, and he has developed what is called the far infrared light technology, and he has transferred this particular technology to many of the Indian companies. He is a known face as far as the physics world, the world of the physicists, and the world of the academicians and the scientists go, particularly in the city of Bombay. And his latest passion has been IKS, and therefore, when someone referred his name, is recommended his name, that he's an authority. It's a very difficult to call oneself an authority, but one who knows about Aryabhatta, let me put it that, one who has studied Aryabhatta. So we were excited. So I talked to Dr. Prabhu immediately, and it's our I must express gratitude on behalf of the BBB IKSL that is kindly consented to be with us. So Dr. Prabhu, we thank you very much for being with us over there. Very eager to listen to you. The floor is open to you, sir.
Thank you, Dr. Sengupta, for such a kind word and such a nice introduction. I don't think I'm really worthy of that. I hope I will stay to the point and whatever you have said. And it has been a great pleasure and honor. And thank you, all of you, for being here for this talk. And, at such a time, I mean, it is a time to go home and relax. So thank you for joining us. And I hope in the next 1 hour or whatever 45 minutes, I will be able to give you some kind of feel for whatever is our, in the Indian knowledge system. It's a very nice thing that the government has come up with. It also tells us about our forgotten, glory of all our forgotten Indian scientists, mathematicians who contributed, and over a period of time, all their contributions had gone completely into the that. Nobody now remembers or acknowledges that. In fact, acknowledging any of that, you are also marked as belonging to some particular political party or something. So it hasn't highly polarized in that sense. So here, of course, we will be taking I'll just give you a brief thing about Aryabhatta and his entire thing, that the glimpses of what he has done, what he has contributed, and what kind of things that he did. And sometimes there are some exaggerated claims which you may read. So I don't want you to really believe in those. And we will just, because what happens is, somehow many times those exaggerated claims, if it turns out to be wrong, even in the genuine things also people start suspecting. So this is something, the danger that we should avoid and really stay true to the point that, what they have done. So before I start, I will first tell you many times people wonder how these mathematicians are. Are you able to see my slides clearly?
Yeah.
So,
Yes, sir.
yeah, so I am from the ultra-fast spectroscopy laboratory of condensed matter. I am professor in TIFR, but I am professor of physics. And this is my sort of passion to do some mathematics. And I happen to be fascinated by our ancestral mathematicians who have contributed. Aryabhatta actually is also an astronomer, and he has done a lot of things in astronomy. So I will show you some of those. Too many technical details I will not be able to give you because they will not be of any interest to many of you. So before I begin, many of you may wonder how come India, we don't have so many mathematicians or something. So what I'm going to tell you is that, you can actually manufacture these geniuses, So these genius who come from anywhere, be the physicists, chemists, biologists, or any scientist, any thinker, philosopher, and a mathematician, you need to manufacture them. Now, what do you mean by manufacture? So I will tell you, just like you manufacture many of these items, toys, or many of the other things, cars, etc. So you may find this word manufacturing a bit sort of odd, but I will explain to you why this is needed. So first, in 9th century, the Indian mathematician Mahavir, he actually gave the qualities for a mathematician. So he has written this book, Ganita Sar Sangraha. This is from the Jain school of mathematics. Jain school, Jain, as you know, Jainism is also a very, very highly regarded set of philosophers which were there in Jainism. And they also had a huge tradition of mathematicians coming in. So mathematics and the philosophy both were going hand in hand. And all these things are, again, I'm telling you, not taught to us in our history books or anything, but these are, for whatever reasons, I don't know. But these are something which are very, very important and should be stressed quite a bit. So let's start with this Ganit Sar Sangraha, where he has written something in 850 AD. And in that, he gives about 7-8 different qualities of a mathematician. So one is, of course, the conciseness, that his ability to express mathematical ideas and solutions in very brief and elegant manner. So this is basically Laghu Karan. So you can make Laghu means small, and you do Laghu Karan means a smaller thing. Then second is inference, that is Uha. Some of you who are Marathi may have heard this Uha Poha. You basically do inference and do to and fro things. So Uha Poha, that word actually comes from Uha and Apoha. So this is the capacity of logical reasoning and deduction to arrive at specific conclusions. So this is just like what those of you who have read Sherlock Holmes, you will see that this is something which Sherlock Holmes will also say. Very logical reasoning, and he will deduce something, and then he will arrive at those conclusions. Then this confutation, which is apoha, that is to skill to identify or disprove incorrect or flawed mathematical arguments. So this takes a bit of deeper understanding and thinking. The other thing is basically analysis, meaning the one who is not, lazy in a way, analysis. So that is very vigor in work and progress. So this person has to be very diligent, and he should have a lot of perseverance in tackling these mathematical problems and advancing this knowledge. Now, other thing is, of course, Grahan, that is comprehension of this person should be very good. He should very strongly understand mathematical principles and ideas. And his concentration of mind is very much important. So that is what is called dharana. That is the ability to focus very, very intently on whichever task, whether it be philosophical, mathematical task, without any distraction. So it is just like You have dhyan, it is like dhyana dharana, that kind of a dharana. Finally, you have this, he or she has to have the ability to find solutions, which is the upai, and this is the resourcefulness and ingenuity in devising methods to solve mathematical problems. And lastly, there is ability to uncover quantities by investigation. That is Yaktikar. And this is a skill that is required to explore and determine some very, very unknown mathematical values. And this you arrive at systematic inquiry. So one can say this is like an algorithm that you can follow and then figure out. So now, again, meaning these are all the qualities for a mathematician. And many of these things you will find, because I see that you people must be from different uh, parts of the society. Some of you may be businessmen, some of you may be teachers, professors, doctors, and many professional uh, tasks you must be doing. So many of these things you must have also followed. And so it is not only just for mathematician, but it is also for, a person to be successful in a certain stream. Many of these things would be very much required. Now, what has happened before I go for this, why we went into dark ages and why we could not manufacture any of these genius for a long time period, is because if you see why, so many of you will ask this question to me, that why Europeans are ahead of us, why these people go ahead, and which are these discoveries that basically led them. So if you go from, say, Christ's time, that is 0 AD, beginning of the millennium, India's contribution to the world GDP was roughly 1/3, 33%. Then, as 1,000 years later, it came down to about 28%. But it is roughly, I would still say that it is there. Then it came to 1/4, around 1500 to 1700 AD. So that is the time when we started getting attackers into India, and they started destroying things. But still they had not destroyed too many local industries. The real destruction started after the Britishers came in after 1757, and then in 1820, within 100-120 years, this became 1/6 our GDP. And then by the time it was beginning of the 20th century, 1913 or so, GDP came down to 7% of the world. In 1950, when we were independent, we were only 4% of the world's GDP. So you can see from 1/3, we came down to 1/16. So it is complete, 1/25. I mean, it is complete destruction of our industry and everything in India. And now by 2010, we went to now up to 7%. Now, all these things, why I'm telling you is that, so it is not an accident that we had all these Aryabhatta, Bhaskaracharya, Varamir, and all these people around 1000 AD or somewhere around that or before that, and not after that. After that, we sort of went into the dark ages, roughly around 1600, 1700 onwards. And that is, so these numbers I want you to remember, that how our GDP was going down from 1/3 to 1/4 and then 1/6 kind of thing. And that basically put us into the dark ages. So what is it that is required for to manufacture, say, mathematicians? One is it requires complete political stability, which we didn't have during that period. It requires educational institutes. We had none. Whatever we had, Nalanda, Takshashila, all of them were destroyed. I mean, they were razed to ground. Nalanda, though, you know that library was, that Bakhtiyar Khilji was burning it for almost 3 months. 3 months he was burning that library and all the scripts which are inside. So you can see the amount of knowledge that was destroyed by Bakhtiyar Khilji. Then it also requires mass education, which is another one that we lack. And that is also because of the caste system, as well as we did not make any inventions of the machines. That is also again a caste based, basically caste based society. That's
कॉपी में क्या होगा उसने कॉपी कर लिया सुनो
so so what happens is when you have political stability, educational institutes and mass education, it actually gives rise to industries, a lot of innovation, because in these educational institutes you have people teaching, students studying, and different things are studied. So you develop technology, you develop different products, and this leads to a lot of economic growth. And that also, improves your health, and it makes a lot of progress. So all these things have contributed. So whenever I ask this question to my students, whom you think was a great genius, this, that, people say, oh, Isaac Newton was a great genius, genius, everything. Oh, that's great. Or Einstein, another great genius. So I asked them, okay, then tell me, if Newton was so great, I mean, the population of England that time was hardly, 30-40 lakhs. Maybe just as big as the suburb of Vashi or Navi Mumbai, whatever. Now, if you have one Newton coming from there, and India's population that time was at least 10, 20 crore, entire India, how much should be how many Newtons we should have? So the thing is, catching people like Newton or manufacturing people like Newton, it is basically a statistical process, because we always have those number of geniuses in the population. Only you need to give them the opportunity. So, for example, that time in Maharashtra in the 16th century, when Newton was in the Cambridge University teaching and doing all the research, what were we doing in Maharashtra? We were all running around in that Sahyadri, Maharaj, they were fighting Aurangzeb and all this. So this is something that where will be education? Where will be that university? And there will be no tradition. So you will not have any access to whatever your predecessors did. So what happens is, when you have these educational institutes and when you have these traditions, you actually carry that knowledge to and fro, and then as a result, you start making newer and newer discoveries, and you catch the right people. If you are constantly fighting, you are constantly having things where you are having wars, destruction, then you don't expect yourself to have people like Newtons or Einsteins coming in. So I mean, the latest example here is you can say Afghanistan, and you can see that there are no institutions, no universities. So there is no way anybody can come in from there unless you have a huge amount of stability. So now we move to Aryabhatta. How Aryabhatta came up. So he was born in Patliputra in Magad. So Magad was a big, I mean, all of you know Magad. That was a very big empire that time. So it has a weak stability, and they also had a lot of tradition. So this is where it says ki Aryabhatta sets forth here the knowledge honored at Kusumapura. So Kusumapura is another name for Patliputra, and which is Patliputra is near Patna, now in Bihar. So he was born on March 21, 476 AD. So some people say that, I mean, in Bihar it is celebrated on 13th April, just 2 days back. That is when they celebrate Aryabhatta's thing. So this is also, I would say, a very appropriate day that you had selected for Aryabhatta's thing. So anyway, now why this March 21, 476 AD is because he has given all this in his verses. So this is the thing that he gave at Ujjaini on Sunday, March 21, 499, when he was 23-year-old. So he gives all these values of where the sun, moon positions, and you can see the modern one versus the one that he gives. They are so close to the correct values. Especially you can see Jupiter, Venus, and all that. I mean, they are very, very closely matching. with this, and especially moon is very, very accurate because of course its close vicinity, and even sun's position 0 degree is equal to 360 degrees. So even if it is 359, it is you can say that it is very, very close to that value. So from these people have figured out what was his birth, what was his birth part, etc. And so this is roughly around March 21, and they say that the positions have not changed much in those 23 years of this. Now the thing is, why this is called Kali at 3600? Basically, it has to do with the nomenclature or the years that he has counted from that. So they say that okay, certain yug has ended and new yug has started, that kind of a thing. And Ujjaini, why is Ujjaini? Is because Ujjaini was also another very famous place where all the exchange of all these astronomical knowledge took place. And Ujjaini is the same as Ujjain in Madhya Pradesh. And even now also, it is a very highly regarded place. If Britishers had not come to India and if we had not been ruled by Britishers, then Ujjaini would have been our Greenwich mean time. So it would have been a Ujjaini mean time for the rest of the world. And Ujjaini's main latitude would have been considered as our mean value for the time. And then everybody would have counted from Ujjaini what is your distance. And that is what was being done in ancient India. So Ujjaini was considered as the center, and Ujjaini Observatory was the main observatory. Just like you now have Greenwich Observatory in UK, where the 0 degree latitude actually comes in. So anyway, it's a part of history now. So Aryabhatiya is divided into 4 sections. That is what he wrote. Each one is called Pad. And there are Gitikas, which are consisting of 13 verses. So Dasha Gitika Sutra has been given, these are 10 aphorisms. In the Gitika is a meter. Meter means it's a vrutta. So some of you may be knowing in whichever language that you have studied. If you have studied in your mother tongue, like in Marathi or Hindi or Gujarati, these vruttas are called Shardul Vikridit and Vasanta Tilaka and all that. These are all taken from the Sanskrit words. So this is a Gitika kind of a vrutta. And these are remaining 3 sections of this. They have 108 verses. So that has 3 parts. One is Ganit, that is mathematics, that has 33 verses. Then you have Kal Kriya, where it will tell you about the how to calculate time, that is 25 verses. And finally is goal. Goal is sphere, that is 50 verses. So basically, Aryabhatta knows that Earth is round and the entire sky and everything, he treats them as round. While, that time in Europe, the Earth was considered flat. And while this one is 1,000 years before, he's already telling that the Earth is sphere and everything. So we will go step by step. So this is his first big thing. So he says that just as passengers in a boat moving downstream sees the stationary trees on the river banks as traversing upstream, just so does an observer at Lanka. So this is Lanka is all the time mentioned by all these ancient astronomers. And I will explain to you the concept of Lanka. This has nothing to do with our Sri Lanka in the south, but it has to do with a particular point in the near Maldives, where I'll tell you, I will show you the diagram where this Lanka point is. So he says that observer who is sitting at Lanka, so it is roughly, you can say it is at equator, which is the Vishuvavrutta. So there is somebody who is standing there, will see the fixed stars as moving towards the west at exactly the same speed at which the Earth moves from west to east. So now you can see he is very clear about Earth's rotation, and he says that all of them are stationary, but Earth is rotating. That's why it appears that this whole thing is moving. So nothing is moving around Earth, but Earth is rotating around itself. So that's why. Now, if you see where this Lanka is, the position of Lanka. So this is from this Ujjaini. Now Ujjaini's number is, the location is 2309 north and 7543 east. So 75.43 east is the latitude that actually goes all the way and cuts the equator. And that is the point at which you will see we have Lanka, which is being mentioned by this. And 23.09, see, Ujjain is very close to 23.15, 23.5 degree north, which is the exact axis of Earth's tilt. So this is very, very close to that on the location wise. And if you are from Gujarat and if you're from Ahmedabad, there is a nearby one temple which is exactly located at 23.5 degree. And there this sun temple is there, and this sun temple is exactly located at 23.5. So what happens is during the summer and summer solstice on 21st on 21st June, you will actually have zero, what I call zero shadow day for them, because the sun will be exactly at the top, and then it will start going towards south. So that is the inflex point, and at 23.5, because Earth is tilted at 23.5 degrees. So this point at an Indian Ocean near Maldives is called the Lanka. It's a, right now you can say it's a virtual point. So because we don't know, right now it is just a sea there. And this is probably just excuse me. This probably also refers to some Lanka point. It is in the south, so of Ravan or something, but we don't know right now. It is all sea there. So now I will show you that if you are standing as an observer in the either in the North Pole or the South Pole, you will see that the stars and everything will rotate around you. Meaning, if you the more and more north you go, the sun and all other stars will continue to move all around you. That's the whole reason that when you cross Arctic Circle, you will see sun in the midnight, because the sun will continue to will never set. It will continue to just move around you in a circle. But if you are at the equator, then what happens is you have exactly sun coming, or all the stars rising from the east and exactly going down in the west in the in a very, very straight manner. I mean, all those circles will be exactly going above you. And if you are at, say, Ujjaini or Mumbai, you will see that the stars will not go exactly above you, but they will make a certain angle, or whatever angle at which you are standing. That is the angle at which they will keep moving. So, for example, in Ujjaini, they will make 23-degree circle. So, this is the circle that you see here. So, I'll just annotate it for you. So this is the circle that you will see that it will move all along that. So these are all the circles that it will continue to. You will see that it is move. The stars are moving at that particular angle. So so I hope that this part is clear. So on the equator, you will see exactly everything going up above you, above your head, and then to the ground, because there the Earth's axis is exactly horizontal. So this way, so this is something which he even knew. Aryabhatta seems to know. So he had this point on equator called Lanka. The North Pole was called Uttar Meru, and Ujjaini was exactly around this. So this just happens to be a very nice coincidence. Now, Aryabhat's astronomy calculations, so he says that the orbit of the sky, so he calls it these like 12 trillion yojans, which is basically 16.8 into 10 raised to 13 kilometer. And this means that the diameter of this it would be like 5.4 into 10 raised to 13, which is 4,600 times our solar system's diameter. And that is quite a bit of a distance. If you consider the time of Aryabhat, where they have no clue about any space things, etc. And this is roughly 10 parsecs. So 10 parsecs is basically the distance between these Earth and Sun. And here, if you see the Sun at that particular position, you will find that its magnitude is roughly 4.7. So if you are so much away, like 13 to 10 raised to 13 kilometer, if you are so much away, you will realize that sun will be almost close to its visible thing. Meaning right now we are seeing sun is so bright, but at this distance, the sun will be like a very faint star that the human eye can see. And it's very strange that a person in 1500 years, 1600 years ago is saying that the limit of our universe or whatever that sphere is this limit. So it's a very, very strange thing. So he also gives one Aryabhat's one earth year of this. So you see that this is a big integers that he gives, and these are something like 1.5 trillion billion days in one Mahayug, and one Mahayug is 43 lakh 20,000 years. And if you do this division, you will find that 1 year comes to 365.25 and whatever 636 days. And this is a way almost exact the same number that we have today for the rotation of this Earth around the Sun. And this is exact. That is the whole reason why after you take it 365.25, and after 4 years. This 0.25 after 4 times repeated, it will become 1. And that's why we have 1 day extra in February, which we account for in the leap year. So see how beautiful and how brilliantly he has found this out. We don't know exactly what instrument he used, but his calculations seem extremely close to very, very high precise numbers. Now, he took Earth as the rotating sphere, and so that was his first thing. He was also criticized very heavily by Varamir and others. What is he talking about? We see everything moving around, so he's just talking like this. So they gave some different examples, etc. But Aryabhat's thing, another thing was that he is the diameter of Earth. So that he took it as 1050 yojans. And this circumference, if you calculate with pi, d, etc., it comes to 44,860 kilometers. This is roughly about 20% off from the exact value that we know today. And remember that Earth is not exactly a sphere. It is called oblate spheroid. Means it is slightly bulged in the equator and slightly flat from the 2 poles. So that's why north-south circle and east-west circles are different for this. So anyway, this is just the matter of detail. Now, Aryabhatta also knows about the eclipses. The moon eclipses the sun and the great shadow of the earth eclipses the moon. So he is very clear about that also. So these are very radical things that somebody in that era would say, and without having telescope and any of this. Now, this one yuga of 49 lakh 20,000 sidereal years, the Earth rotates eastward these many times and the moon these many times. That is what he has given in Gitika 3. Now, if you see these numbers, again, you will find that these are very highly precise values that you get. He's not talking about fractions. He's talking about big integers, because these big integers, when divided by the other number, you can find out and you can do the calculations yourself. So integers is something they were very good at, and I'll also tell you the reason for this towards the end, and you will find that why he deals with such big numbers and not the fractions. Now the next thing was the earth rotates by an angle of 1 minute of an arc in a prana, that is 4 sidereal seconds. So this is something that he tells. Now from pran, what do you get? What do we call pran? All of you are familiar with pranayam. So it is pran and ayam. Ayam means a period. Okay. So pran is something that roughly, I'm telling you, if I was in the vicinity in the hall, I would have asked you to take a deep breath and do something like 10 deep breaths, and then you could have just counted the time, and you will see that roughly it will take you 40 seconds and for the 10 things. So this is a period of you are taking one full thing, like this takes 4 seconds. Roughly you check, and you will realize that how brilliantly, when there were no watches that time, how our Indian ancestors and geniuses, as I would call them, they had way of measuring this. Okay, and there is a specific logic behind making such kind of a measurement. Okay, so and this will be true for more or less all the population who are doing breathing exercises. It will take 4 seconds unless somebody is really unwell or something. But this will always be true. You can check it for yourself. After the lecture, you can check. The rotation of the earth causes the nakshatra din. So here I will have to spend little bit time explaining to you. So there are 2 types of dins that are the days that you can define. One is a sidereal. Sidereal means in Latin, that what that means is it comes back to the same position of the star. So for us, we call it nakshatra. Nakshatra means it's a specific set of those stars in the sky. So Earth, after one rotation, so suppose today night at 9 o'clock, you see some nakshatra at some position in sky. So tomorrow night at 9 p.m. exactly, if you want to see that, you will find that the time that you will measure for that position of those stars to come exactly at that particular point will be different than 9 p.m. It will be slightly, that thing will come slightly earlier than normal. So you will say, oh, I have to wait for some more time to, how is that possible? Some error. So there is no error. So this is called sidereal day. Okay. And then when you have this Earth rotating exactly at 360 degrees, that is again coming back, that time is the solar day. So these are 2 different things that you have to know. Now, here he says that that Lanka wala thing which I mentioned. Now, this is where the Lanka position is. So you will see that this is the equator point and the Lanka position. So here is Ujjain is somewhere here in this position, and you will see that he draws this line that actually cuts at this particular point. So this is the point which is quite deep into the near Maldives and all that. So this is the point at which he calls it as Lanka. So this is his Lanka point. So now you will say there is no land here or anything. Yeah, that is absolutely correct. But this is what all Indian astronomers refer to as Lanka, and this is how they calculate. So here is the equator. This is the celestial equator. Basically, celestial equator means when you just look up in the sky above your head, you will see a particular line. If you are standing on the equator, so that is the celestial equator line. Now, from Mumbai, you will see it slightly to the south because equator is to our south. So you will see it slightly moved around. So we are somewhere, this Bombay and Ujjain, we are slightly to the western side of Ujjain and to the south of Ujjain. So these are some intricacies that he had. This is what I again explained to you, that if you are at the North Pole, everything will rotate around you. If you are at the equator, everything will go from east to west above you. And if you are at Mumbai or Ujjain, the stars and all the stars will actually do a tilted circle around you. So this is something which I wanted to again repeat. Now, the nakshatra din or sidereal is a time taken by any nakshatra or a fixed star to perform one complete revolution around Earth related to the observer on Earth. So that is what I told you, that if you mark certain star at say 9 p.m. today, you will again see that star coming exactly in that same position. That is the time that you call it at a sidereal day. Now, what happens is during this period, Earth has made a complete rotation around it, because you as an observer has actually seen that particular nakshatra or that star has come back to its original position. Now, there is a slight difference. So, if you look at the star rise from say eastern horizon at a particular time today, it will rise again tomorrow, but from the same point, but about 4 minutes earlier. Now, you may wonder why it is taking 4 minutes earlier. Now, if this happens every day, so every day this star will come 4 minutes earlier like this. So, after complete Earth's rotation around the sun, so that is roughly 365 days or something. Now, you will see how much time it will be. So it will rise about 1 hour earlier after say 15 days, because that is 60 minutes, that is 1 hour. 2 hours in 30 days, that is 1 month. So in 12 months, it will be 24 hours. That means it will again come back exactly from that after 1 year. So, so basically Earth has completed 1 year, so that's like that. Now, this sidereal day differs slightly from the commonly used civil day, comprising of 24 hours. So, the civil day that we call of 24 hours is called Sawan Din, or the solar day. And this length of solar day is the time taken by sun to go around the Earth once. Now, this is different than the Earth's rotation around itself. Now, this happens, why I will show you in the next figure. Because what happens is, Earth has rotated around itself, but it has also moved around the sun. So now, Earth has actually shifted by certain distance. So now, if it sees the same movement, and if you want the same position to come, Earth has to slightly rotate a little bit more, and you will see that here very clearly. So this is Earth's complete rotation around itself. So it has come back to its own position, but the sun will not be there, because sun being a nakshatra, I mean it is also part of a nakshatra. It has, the Earth has moved, so sun has moved. So now Earth has to go a little bit more to cover up for that. So what happens is, the rotation around itself, it takes 23 hours 56 minutes, but when it goes to exact sun, then it has to do 24 hours. So that is 361 degrees. So it has one slight degree additional. So that's why after 360 days, degrees it will be happening after 360 days. So that's why you have a complete 1 year rotation. So this will make it clear for solar day versus the sidereal day. Now, this is the Indian measurement system, which is also heavily used by Aryabhatta. So you have 30 muhurat, which is 1 day, that is 60 nadi, and 1 muhurat is 48 minutes. So that is equal to something like 2 ghatka or ghatika. So as you know, there is a ghatika patra around marriage time, and they say, okay, when it comes the lagna ghatika or whatever is close by. So this is that ghatika. It is every 24 minutes. It keeps repeating. Now that is again further defined into Vinadika into 60 Vigati or Gurvakshar. Now what do you mean by Gurvakshar? So how do you measure such a thing? So Gurvakshar is basically Guru Akshar. That is what the word that you have to say. So now if you go and say Guru, 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 this word, you will realize that it will take less than a second to say Guru. And so if you do this, say 100 Guru word, one after the other, without stopping, it will take you roughly 40 seconds. So that means one Guru Akshar, when you say, it takes about 0.4 seconds. Now, if you calculate with that, you will realize that it will, with respect to that, it will tell you how many of these. So 10 gurus will come to one pran. Pran, that is your one, breathing in and out time. Now this takes roughly about 24 seconds, 6 prana and all that, and so that actually will lead you 1 day to 24 hours. So now if you calculate our usual seconds in a day, 24 into 60 into 60, it comes to 86,400. And in the total seconds in sidereal year, which is 366 sidereal days, it comes to 316,22400. And it is not exactly 365 days. Now, if you have a calculator, you can take a square of this. So, okay, so if you do the square of this, I would have asked you there on your mobile to do it, but now I will tell you the answer. If you do this, it will come out to be 9.99999, something like that. So basically it is a 10. So this number is the square root of 10. So it's very, very unusual, but that's how it works. Now, Aryabhat's calculation, he actually gives this number 23 hours, 56 minutes and 4.1 seconds. This is extremely close to our current estimate of 23 hours, 56 minutes and 4.09 seconds. So you can see how close Aryabhatta was with respect to this. So he gives all these accurate values for the rotation. He also gives the moon's rotation around the Earth, and which is 27.3964. Now, this is a correct value if you, because moon actually slows down a bit. So if you go back with that correction, 500 in say 1500 years back, it is correct up to 7 decimal digits. And if you take the full 10 digits accuracy, then you go to this particular year 1604 before Christ. That is 1600 years before Christ, whatever was moon's rotation around that matches exactly to 10 decimal places. So you see, this is the accuracy with which Aryabhatta gives these numbers. So it's still a mystery how he found this out. We still don't know, but these numbers are given in there and you have to just take it. And all Indian astronomers used to use these values. Now the value of pi Aryabhatta gives is 3.1416 and the actual value is 3.1415926. So you can see he is very close to that. And he also mentions that this is an approximate value, not the precise value. And this is 100 years before the Madhavacharya and all those, they all calculated the pi value. And this is again 250 years before Newton or Leibniz or these people gave their formulas. Now I will come towards the last part of this. So in the Gitika 3, he gives one yuga to be 43,20,000 years. Now this is special number. I will explain to you what this special number means and why it is chosen. But Earth rotations on these years are these, moon rotations are these, and this gives you the precise values, and that you can already see. The lunar orbit value also is very, very accurate. But what is this 432, 43,20,000? This is actually 20 into 60 cube. Now, what is so special about this number? The special thing about this number 60 is this divisible by so many different numbers. See, you see this entire number is divisible by 2, 3, 4, 5, 6. except 7, it is all divisible by all other numbers 10, 12, 15, 16, 18, 20, 24, 25, 27, 30, 60. So you will see that many of these our nakshatras are 27, hours are 24, days this 15 and first of all this 2, 3, 4, 5, 6 up to 8, 9 and 10 except 7, everything is divisible. 7 is only not divisible. And I will see how that is taken care of by our Indian mathematicians and this. So one yuga is this many days. So this means one year is 365 days. So here also he calculates this very, very accurately, 6 hours, 12 minutes and 20 seconds. Now Brahmagupta had criticized this model by asking that if Earth is moving so fast, so the ball will fall from the mountain top, should fall down about 8 miles away in 2 seconds. But that time, of course, the law of gravity was not known, and so of course Aryabhatta probably could not have that. But all these values, they remain the same. Now I will give the last example of the Jupiter. The Jupiter rotates these many times, 3,64,224 in these many years. So this amounts to 11.86. The current exact value of Jupiter's movement around the sun is 11.862. So that is what you will see that in the Kumbha, the Mahakumbha comes 12 years after the rotation, because the Guru, that is Jupiter, makes complete round around the sun in 12 years, and it is not exact 12 years, it is 11.86. So there are this big Mahakumbha or something has to come after 12 such rotations around that. So all these calculations, these are very precise numbers which they have already given. Now moon's diameter, the current diameter is 3474.8. This he gives as 315 yojan, and Earth diameter to be 1050. Now if you see the ratio of current values, this is 0.2724 given by us, and Aryabhatta's ratio is 0.3. So you can see it is quite close. Only he makes a mistake in the sun's diameter, which is he gives as 4410 yojan, and that's what sun to earth ratio is 4.2, but actual modern ratio is 109 point something. And this will also tell you the ratio of earth to sun distance versus the sun diameter is 107, and ratio of moon earth distance to moon diameter is 110, and these are somewhat close to 108. That is a number that you probably know, which is very common in our Hindu these things. So anyway, now I come to the part which I explained to you why our mathematicians like Aryabhatta has given these big integers. So now it will become clear to you why they are doing this, and it has to do with our language. And all of you, irrespective of whichever Indian language you are speaking, Marathi, Hindi, Gujarati, or any other, you will now see the parallels of those in this. And I'm quite sure that most of you have taken your education in your vernacular language, and you must have done all these, we call it pade, that is the tables, 2, 3, 4, 5 tables up to 30, or some of you may have done up to 40 in your childhood. So now you will start seeing something parallel into that, because it is part of our culture. Now you see, forget the first line of this. This I want you to concentrate on this Q group. If you try to see what is the meaning of this, there is no such meaning. There is no Sanskrit meaning to this word. But this is a mathematical representation of a integer that I will show you how that thing is there. Similarly, this is another Ginshibularukshkru. This is another one that is representing another number, but that you can figure this out later. But this is what is the actual shloka given by Aryabhatta. And now I will go to the next part. So this has to do with the following thing. Now let us look at this Q-gru word. Okay. Now, you have to know what is known as a Katapayadi method of our Indian people trying to trying to sort of write down the values into the our syllables. So because of this, what happens is many times it becomes very difficult to figure out. You may read like a shloka, but you do not know that whether it is a representation of a number or what is it is telling. And the second thing is, they also say Ankanam Vamato Gati. Vamato Gati means the Anka or the numbers are written. We write it, say 47 as 4 and 7. But the Indian method or our method, language method is ulta. So for example, 47 will say 40 and 7. So you have basically 40 followed by 7. So 47. Now in your own language, just see how do you. So those who are Hindi, they will say Saita Lis. So Saita is to do with 7 and Lis, Chalis is 40. So now you see, we write it in exactly opposite form. This any number you read, in Marathi we will call it Satte Chalis. So Satte and then Chalis. So basically 47 is represented exactly ulta by us when we speak. So this is a typical true of all the Indian languages. You can probably just get back and check. Now here we go back. So here you will see that Y is represented by 30. Okay. R is represented by 40. Now you will say, what is this? Now I will say this is Y, R, L, W, Sh. Sh. It's like, no, you sh, they are all the same. Now, as an Indian, you will immediately understand what I am actually talking. This is her. This part is her. So now you see, depending on how you pronounce it, it will also carry a different value. So this is Y, R, and L. So here what we have? Here we have K. So let us wait for the K. Now, Y with a U. Now, U has, so this gives you a U. So U has a particular value, which is actually 10 raised to 4. So when you multiply these two, it gives 3 into 10 raised to 5. Now, this is She, this is Shru, and this is Ka, Kha, Ga, Gha, Nga. So Ka is 1, Kha is 2. So if I write Q group, I have Kha, which is actually 2. Then here, from here, so I will write as 30. Then I have U. U is 10 raised to 4. So I will tell you that in the next slide. So now when I write Q, I have Kha, Y, and U. So I have 2 plus 30 into 10 raised to 4. So 32 into 10 raised to 4. So that leaves 32 into 10 raised to 4. Then I have Gha. So now see, Ka, Kha, Ga, Gha. Gha is actually 4. So I will write here 4. And then I have Gru. Gru is basically, that is this. This I am actually giving you in the Devanagari. So you will have similar things in Gujarati and other languages also. So this Gru will be 10 raised to 6. So you have 4 into 10 raised to 6, 30 into 10 raised to 4 plus 2 into 10 raised to 4. So the total comes to this number. So when I say Q Gru, I am actually representing this as 432 into 10 raised to 4 as a number. So you will see that how difficult this was for him to do this. But this is again part of our culture. It has gone through several thousands of years. So it is also part of our language. Now, so here he gives in his verses, in the Yuga, the eastward revolution of sun is this. So this is the translation of this shlok, which I told you. Oh, sorry, this slide got missed. Sorry, I'm sorry. So after this was the slide where you have O, A, E, U, A, all these. They represent actually 1, 10, 100, 10 raised to 4 like this. And this way, he was able to go up to 10 raised to 18. And then he was also able to go extend it up to 10 raised to 36 because he had to deal with huge numbers, very large numbers, astronomical numbers. Now here you will see that this is ka, kha, ga, gha, nga, cha, cha, ja, jha, nya, ta, tha, da, dha, na, and ta, tha, pa, bha, ma, ta, tha, da, da, na, and pa, pha, ba, bha, ma. So all of the Indian languages have this. I'm 100% sure all of you will identify this, and that is the whole reason that whether you are a Gujarati, Hindi, or Marathi speaking, or Tamil, Telugu, whatever, if you know this language, Sanskrit is basis language, you can immediately figure out as a Jyotishi or astronomer what is the what are the numbers and what do you mean, and see how brilliantly this whole thing can be translated. So, so Khugru, now you will realize that this is actually this number that he represents. So same way, you can actually also figure out what is this number going to be. So this you can figure out at your own time. But this is how it is. Our Indian ancestors did this to pass it on. So this is what he is actually telling in the whole thing, that the sun has eastward 43 lakh 20,000 of the moon. Then the moon has 577, 53, 336. Earth has these many rotations. So all these now integers, you just have to go and divide by 3 to into 10 raised to 4, and then you get all the fractions patapat. So there is no question of you missing out on dots. Dot either ra, udar ra, nothing like that. Everything is now becomes very clear. So you see how brilliantly they did it. And this is where he actually gives these numbers, which I actually showed you those the numbers. Now these are the actual numbers that you can see from Aryabhatta, and so you can find out all these fractions, and you can compare them with the modern ones. So you can see they're very accurate to a large extent. Now, the last part I will finish. I'll give you some influences of ancient Indian astronomy. So first is how our day names have originated. So many of you may be wondering. So these are the order of planets as per their period. So if you see, Shani takes roughly, that is Saturn takes roughly 30 years. Then Guru takes, that is Jupiter takes 12 years. Then Mangal, that is Mars takes 2 years. Followed by Ravi, that is here I'm not putting Earth, but I'm using Sun because Sun rotates around, comes back to its original position in 1 year. So this is how you have to calculate how Mars comes in the same position, how Jupiter comes in the same constellation, like that. So Shukra and Buddha and Soma, basically the moon, they all take 1/12 of a year or 1/4 of a year, etc. So if you go through all of this, you have to put them in this order, okay, as a descending order. Now the thing is, when you want to give the name for a given day, because there are now 7 planets, and all you saw that the previous integers, everything was 60. Everything was divisible by 2, 3, 4, 5, 6, except 7. Everything else was getting divided. So how do you basically reconcile this? So they decided, okay, we will basically put them these 7 planets in this order of decreasing time. And then you start at say 6 a.m. So 6 a.m. let us allot it to Shani and call that particular day as Shanivar. So let's start with Shani. And then after at 12 p.m. you will have Soma. Then again 1 to 7 p.m. you have the same cycle. Then again 8 to 2 a.m. You will again see Soma, and then at 3 a.m. in the morning, Shani will again come. So this is the next day of Shanivar, early morning 3 a.m. Then at 4 a.m. you have Guru, that is Jupiter, and at 5 a.m. you have Mangal. But then at 6 a.m. you have Ravi, that is the sun. So therefore, after Shanivar, on the next day at 6 a.m., you will have Ravi, which is there. That's why it will be called Ravivar. Now, so after Shanivar, you will have Ravivar. Now again, go through the same allotment. And the next day after Ravivar, at 5 a.m., you will see Buddha coming in. And at 6 a.m., you will have Moon, which is coming in. So Moon is called Soma. So therefore, after Ravivar, you should have Somvar. Now, if you follow all this cycle, after Somvar, you will have Mangalvar, then you have Budhvar, then Guruvar, and then Shukravar. So that is how all these names of the planets, you can put them one after the other. So this becomes very, very clear. So see, there is a particular logic behind this. It's not some random thing. And so you will see this. And before I end, this is the last part. This is again, of course, I do not know how this what this means, but I just want to show you that there are too many things which we don't know yet and we do not understand. So here is something that is written as a commentary on Rigved's thing. So here it's written that Tarani Vishwa Darshato Jyotish Prudasi Surya Vishwamad Bhasi Rochanam Tarani Vishwa Darshana Jyoti Prut Prasi Surya Vishwa. This is actually part of the Rigved, and there is a comment. This comment was written something like in the 1100s or something like that. And there he says, this is the line that I want you to concentrate. Yojananam sahasre dve 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 shate dve cha yojane. Now, as I already told you, that Ankanam Vamto Gati, that is what you have to say. So Sahasre, that is 2 Sahasra. So Sahasra is 1000. Then he says Dve. So Sahasra and then 2. Okay. Then Dve Shate. So Shate is again 100. That is 200. Again Dve. Then again only Dve. So you see now, I have written 2000, 202. So this comes to total 2202 yojan. Now this ekena nimisha ardhena karmamana namostute. So this whole thing is being traveled in half a nimish. Now half a nimish, if you are not familiar with this nimish part of our calculation. So just like you have all those nadi and ghatika and all that. So nimish is a time that you take to flip your eyelid. And this again, I would have asked you to do this that experiment in the room. But now that we are not in front of each other, but later after the lecture, you can do this in 10 seconds. You calculate how many times you will flip, and it will roughly come to something like about 200 milliseconds. That is 0.2 seconds. So this is a very fast movement that happens, and you cannot just time it with 1 or 2. It will be very, very fast. So you have to do it large number of times. So that is half nimish, and if you calculate this value comes to, this value comes to 200 milliseconds, and this is 2220 yojans in 1 second. So if you take this as 13 kilometer, this comes to 286 thing, and this is the speed of light, which comes very, very close to that. It's a strange thing, but we still don't know how this number has been arrived at. But they just seem to know this knowledge. So yeah, so this brings me to the end. So I wish to thank some of these references. He's a very scholar, Professor Amartya Kumar Datta. He's from ISI Kolkata. He's my contemporary close friend, and he has written beautiful articles in Resonance. So I have been actually most of this thing I have followed his line, and also the original Aryabhatta, but here that I have read. So this He's a very eminent mathematician. So this is his sort of a side, what I call it, his hobby or his passion, and he has done a wonderful job. He was a student of Professor Sridham Abhyankar, another very eminent mathematician in the world. He used to come to TIFR. He did his PhD from TIFR, Professor Amartya Kumar Datta. And his student, who is now another very eminent mathematician, she works in ISI Calcutta. She's a winner of Bhatnagar Award. Her name is Professor Neena Gupta. She follows this Jain in the Jainism thing. So that tradition continues of all these mathematicians. So with this, I would like to thank all of you, and thank you, Professor Sen Gupta, for again giving me this opportunity to talk to all these people. I hope I have not taken too much of your time and didn't bore you, because this is a little bit a cluttered subject. So thank you so much, and all of you again for being here. Thank you for your time.
Thanks a lot. Thanks, Professor, for that fabulous insight.
Thank
That was a wonderful session. So we'll spend some time, 15 minutes on question answer if you've got anybody. Yeah. You can unmute yourself and you can ask, please. Sir, you can close the presentation.
you.
Sir, you
Shall
can.
I share the presentation again?
Yeah.
Okay.
Sir,
No, you can
I have
close
a
it.
question, sir.
Sir,
Yes,
1
sir.
minute.
Sir, this earlier days, a day was considered to be from sunrise to the next sunrise. When did it get changed to midnight?
No, that is from the British people. It has nothing to do with our astronomers always counted it from sunrise to sunrise. So we always were very clear. It is the Britishers or their thing that they shifted it to 12. Because they wanted something to reset the time, because something else happening at say 6 a.m. in the morning, it becomes sort of that number will keep fluctuating. So best is you have one particular unit which is at say 23.59.59, and then you have all 0, 0, 0, 0, 0, and then you reset. So you restart. So that was the most convenient thing, because what happens, say in Mumbai you will have certain time for time rise, sunrise. Then in Kolkata you will have different, Delhi will have different. So having so many variations, because sunrise is very much dependent on your local position, geographical position. So the consistency of 12 midnight is common for everybody. So there is no question of you connecting it to any nakshatra or something. So that way it is very convenient. So convenience wise, I would say it's a very good thing to do. Because whenever you stick it to one particular...
Thank you, sir. Thank you, sir.
Yeah.
Anybody else has a question?
Sir, just I have questions, maybe related and not related. One, sir, thank you very much. It was mind-boggling listening to you, all those, which clearly proves whether we want to believe it or not, everything in nature is all mathematically structured. Every breath of us, everything. And of course, we know Vedic chanting, everywhere this mathematics was given importance. Two things that surprised me is, as you said, we do not know whether he had a telescope. What was that method through which he could infer all this? Because when I think of Aryabhatta, even Ramanujan comes into my picture, because people say that he had never had given the steps, but ultimately whatever solution he had given could not be disputed by anyone. That intuitive method, which now the foreign Americans accept as one of the method beyond rationalism, because we say imitation, conditioning, rationalism, and later on now they have accepted intuition. So to know what is outside, internally getting it, I do not know. That seems to be something really this thing. And another is just out of curiosity, because I do not belong to mathematics field. People who are exposed to major in mathematics or anything, are they exposed to Indian history of mathematics or any part of it? They are exposed, or out of you out of interest, people go into that field, they learn it. I just wanted to know out of curiosity.
Yes, a very nice question. So first answer to first question is we do not know whether what kind of instruments that he used, etc. Because see, lot of knowledge has been destroyed in several years. All these probably the instruments which they use, because having such an accurate measurement, it is not possible by intuition or anything. You must be having some kind of instrument to measure this, because if we are able to keep so accurate time, measurements of time, definitely those people must be having some instruments. However, none of their designs, nothing is available. All of that must have got destroyed in the fire, or these Khilji Bilji, all these people must have destroyed that. So because of that, we have no idea. But what is remaining is this knowledge. So for example, all these, whatever he says in this is all that is passed on verbally. So you see how brilliantly our ancestors have done it. They actually could put in all this knowledge in terms of integers, basically encrypt it in this small words, and then transmitted it from generation to generation. Because if these people are destroying, then at least verbally it gets translated. Sometime it will get written down and all that. So that is what has happened. So that has saved us at least this. But the knowledge that how they arrived at it, that was lost. So that is because you cannot translate a diagram in this fashion. There is no way anybody can do that. Now the second question is that you ask whether this history of mathematics is taught to us. The answer is no, because we all follow this Macaulay's thing. So over years, this has gone deeper into that. All the Indian thing is really bad, and these Indians did not really contribute anything, and they were all just hanky-panky and all that. So this is actually required by any ruler to tell whichever other country that they are ruling, that to tell you that all your previous culture, all your knowledge, everything is bad. That's why we are your rulers. And this is a fact. I mean, anybody will do that kind of a thing to diminish that. But now that we are coming up, we are reviving, we are questioning whatever we learned, whether how much of that was true, how much was fed to us as a falsified thing. So all these things have now come up. There is a lot of research that has been going on. For example, Britishers said that, oh, Aryas came and they invaded India. That is something history which I am sure all of you must have learned. But now genetically it was proved that we are part of the same genetic pool. There was no such invasions or anything. But they wanted it to be like that, because you see, they will say, oh, see, thousands of years ago, all these Aryas came and they basically killed you. So now we have come to do Raj on you. So you are anyway being ruled by outsiders only. That is all your histories. So it becomes sort of, this is, fate accomplished. Je hai, wo hai. हम ऐसे ही मार खाते आए हैं, तो ऐसे ही मार खाते रहेंगे. That kind of thing you have to build. These narratives you have to build. That was built successfully by teachers. So I would not blame them. But now to continuously believe that and all these Arya Dravid theories and all that, to basically separate out people racially and all that, we should not now get into all, should not fall prey to all this. So the answer to your thing is that all this has been suppressed. So now that people have, they're having more access to things, more and more people are getting educated. They are now getting into this. What was the thing that was left behind? And they, being mathematicians, being scientists, they also have their own fields. They look at it, and they are now discovering newer and newer things. Let me tell you, there are 1 lakh, more than 1 lakh these scriptures which are not yet deciphered. Okay, so remember, there are much more hidden things are going to come out. So over the years, now that everything is getting digitized, probably the AI and those machines will also start deciphering. So a lot of those things will happen. So there is a lot to explore. And we have recently just completed one biggest genome project of Indian genome mapping. So that will also be coming out their results. That will also tell us much more about all these racist theories that we have been taught. So we have been product of this very British led history and those. So you have to now question all those things and just, I mean, okay, okay, we had a bright history, etc. That's fine, but you have to also worry about what is it that we are doing present and what will be best for our future. And those are the things which matter a lot, because saying that okay, we had this and that, okay, fine, that's okay, you be proud, but you know, Chinese will also come up with oh, we also had Chinese great people and all that. But now see what they are doing and what we are doing. So this is something I would, you know, be proud of your history, but at the same time, don't be too much. That's what I would say.
Thank you so much.
Hello.
Hello.
I have a question. I have a question, sir. Prabhu sir, I
Yes.
have a question. I am from Udupi. My name is Padma Kini. Actually, it is a very interesting, innovative session. Thank you for that. And I like the well said, sir, about what you said is manufacturing mathematicians. But this is not happening in India.
No, we are, see, we have just got freedom like last 50 years. And to build this tradition, see, when Newton came in 1640, 1660s. But remember, that Cambridge was 400 years before him.
Yes.
It was already running. Okay.
Yes.
So you already had all those people who were teaching him. Okay. So he was not some roadside, he was not sitting under some tree and he suddenly got it. Because just he saw apple falling. We also had people must have seen so many nariyals falling from the trees and many other things falling down. But why they did not get that idea is because they didn't have any knowledge about the previous part. Say, for example, Newton already had the data of Copernicus and Tycho Brahe and all this. He already knew these are the things that these people have been thinking about. But unless and until you have all that, then only you come up with some idea. This is the idea. This works.
Very true. Very true. Yeah.
You have to have that tradition. And we are right now building that tradition. We have Tata Institute of Fundamental Research. We have this Institute of Science in Bangalore. Now we have so many IITs. We have so many ISERs. So as you increase this number, there will be also number of people who will be employed. There will be a large number. So you increase this pool of scientists. And then it's a statistical process that somebody or the other who will come with that kind of knowledge will suddenly just make a break. So this will happen, but that takes time to build this tradition. In TIFR, we have built this tradition since 1950s, that the time that TIFR came up. But other institutions will also take time. The other solution which the China has, that also I'll tell you, what they have done is they have actually bought, I'm saying bought, paisa deke. They have bought these scientists, mathematicians directly into their Chinese universities. They say, okay, chalo, I will give you $1 million per year ka. This is your salary. You come and build your group. So these are Nobel laureates or very highly accomplished European and American scientists. So they come, and now what happens is with them, the Chinese students, they interact, and as a result, they start getting, those ideas. See, for example, if we are in the vicinity of, say, Aryabhatta or Bhaskaracharya and all that, then you would naturally create those pool of people. So it is very, very important that you have to have these people around you. Then you build up the entire tradition. They change your way of thinking. They change your way of, attacking a problem. So you need to have these humans. And these humans are already manufactured in Western countries. So since Chinese could not manufacture right now, they are just buying them. I know. And now they are telling me, now let us manufacture in China. So we have to do that. But that requires a lot of money. So unless India puts in a lot of money into this, this is not going to happen. So this is the problem. We are poor country. So that is why these are happening. As our economy grows, you will see that these things will happen.
Sir, I have
Thank
a
you, sir.
question.
Thank you.
Sir,
Yes,
I
sir.
have a
Yes,
question,
Dr.
sir.
Khan. Yes, Dr. Gadli.
Sir,
Yes, sir.
Professor Prabhu. Yeah. See, firstly, sir, thank you very much, sir. It's a wonderful session.
Thank
And actually, it opened our eyes to how much our ancestors were looking at nature. And from nature, they were observing so much and coming out with theories. That is
Yes.
itself is so. Today, people are getting more and more disconnected with nature because
Yes.
of various things, technology also. So I have two questions.
Yes.
When the concept of time and the sundials that you see either at Jantar Mantar in Jaipur or in the Konark Temple or Modhera Sun Temple, which you mentioned,
Yes, Modena.
they would have drawn upon the theories of Aryabhatta only, no, sir?
Yes, yes.
My
All
second
our
question,
ancestors.
and my second question, sir, is do we, I'm sure we also had a contribution in developing calculus, but that is
Yes.
not told much out. So could you
Absolutely.
please, yeah.
Very brilliant. So, thank you for pointing out that I actually visited Modena. I was in Ahmedabad and we actually went to that temple. And there I actually took out my mobile and I have this, this GPS. It gives me a precise location. And I tell you, it gave me 23.50 precise location where the Earth's tilt is there. And I was standing exactly below the that Kalas that you call it. I mean, the at the top Gopuram of that, the center sanctum that you call it. So I was standing exactly below that, and I can actually, I was shivering. Ki, Arey, this is really so precise. And this is thousands of year old temple. So how brilliantly our guys must have done it that time is unimaginable. So thank you for pointing that out, the Modera place. And the second question you had asked was about the calculus. Now, the thing is, I did not mention here, but Aryabhatta has actually given certain things to calculate beyond the sine table. So he uses that table actually, certain values of that table he has calculated. Now, the thing is, sine, cosine, tangent, all these values you learned it in mathematics. Now, I could actually tell you now how this happened. It was Bhaskaracharya who made this table first time completely. That is, and he called it as Jya Sarani. So this is the Sanskrit word for that, Jya. So this is Jya. Huh? Okay. So in English, it is J-Y-A, Jya. Now, what happens is this was actually translated into Arabic. Now, in the Arabic, they called it Jiba. Okay. This was how that Al-Biruni and all that, they translated Jiba. And he said, called it Jiba table, whatever, or Jiba Sarani, whatever. Now, this Jiba was actually further translated into Latin. Now, that fellow, the person who was translating this, he said, what is the Jiba means? So he actually realized that it means a cave. Okay. Now, cave in Latin is sinus. Okay. So all of you, if you are a doctor, you will know that sinus ka problem hai, naak wala, huh? So the sinus means that's a cavity or cave. So he called it as a sinus table. And that is how the word sine comes. So you see, we call it sine, cosine, etc. But its origin is Bhaskaracharya.
Oh, okay.
And he gave a complete value. And now, see, basically, this is the formula he gave. D of sine theta is equal to this cos theta d theta. So this is a very famous thing. Actually, d sine theta is cos theta d theta. I'm sorry for writing this because this is I'm doing it with annotation, so it's not coming out right. And there is a Kerala school of mathematics led by Jeshtadev and Madhavacharya. This is called Madhavacharya, and that was in the 13th century. And those are the people who actually developed very high level of calculus. but it was all written in Malayalam, so that could not be. It was not brought out very much because afterwards it again went into dark ages. But they were the ones who actually calculated the value of pi, and they said that it can go to a very large number of values, and this is a continuous fraction. It is not a approximate thing. Like it is a unending fraction. So this was actually shown by our the Malayali mathematicians. So you can call it a Madhava series or whatever. In fact, I teach that as Madhava series to my students because, and then there were some guys, they branded me, oh, I am sapronizing. I said, there is no question of sapronizing. What is sapronizing? I mean, we have to give credit to our own people.
Correct.
I mean, where is the sapronizing in this? This is something which you have to be honest about. You look, boss, this fellow did it. You give credit to him. I'm not giving some arbitrary credit to anyone. Right? So these are the issues which happen because he's so much polarized that anything you say good about Indian scientists, then this fellow is ultra. It becomes a big problem.
I know.
I hope you understand.
I understand, sir. Thank you very much. Thank you, sir.
Okay, Dr. Prabhu, I think time is up. It's already 6:35. So thank you very much, Dr. Prabhu. I think it was an exciting, insightful session. We could not take all the questions. Is bound to be there in such an exciting topic. We thank you very much, first of all.
Yeah, thank you.
We look
Thanks a
forward
lot.
to see.
Thank you very
Look
much.
forward to
All
seeing
of
your
you
help
for
and
your
cooperation on
comments
it.
and everything.
Thank you very much.
Thank you.
Excellent.
Thank you,
Eye-opening.
sir.
Thank you. Thank you. Sure.